So let us discuss about two-dimensional motion or 2D motion or motion in a plane. We have learned straight line motion, that is the particle is traveling in a straight line where to describe the location of the particle, position of the particle, whatever, we need only one coordinate axis. So we have chosen x axis but here it is motion in a plane. For example, this paper is a plane and an insect is walking on the paper. So you need two coordinate axes to describe position of the insect at any time. Say these are the coordinate axes and see this is the path of the insect on the paper. Now we describe position of the insect by the coordinates x and y. So this is x and this is y. Two coordinates are necessary, x and y. Right. If it were three-dimensional motion, we would have needed three coordinates. In 3D motion, suppose the example of 3D motion is the mosquito flying, so it's in space. So we should have three coordinates x, y, z to describe position of the mosquito as it flies. However, now for the time being we are discussing two-dimensional motion. Okay. So here say at a certain time position of the particle is this, coordinates x and y. So this is x and this is y. Now say it's traveling in such a path. So here this is the velocity vector of the particle v. Okay. Now this velocity has components vx and vy. So obviously we know that vx is rate of change of x, vx is this dx by dt and vy is dy by dt. And suppose the acceleration also has two components, ax and ay. So here how we will deal with this two-dimensional motion is that as the particle moves in this path, we can split it into two one-dimensional motions. Let's say if light falls, there is a light beam falling from here. So as this particle moves along, say this is the starting point and this is the end point for a certain interval of time. So you can see two one-dimensional motions, right? So this particle going from here and here also, here see, as this particle goes along, if you have a parallel beam of light like this, you will see it going from here. Maybe it will come back, whatever, but it is split up into two one-dimensional motions. Now we will deal with the very simple case, that is 2D motion with uniform acceleration. Acceleration, right? Okay. Now see, say this is a coordinate system, this is a certain coordinate system x and y, and suppose the particle starts from here, moves along this path, right? So the initial coordinates of the particles are x naught, y naught, and at a certain time the coordinates are x and y. It may travel further. Okay. So this is at time t equal to 0 and this is at time t equal to t. And suppose ax is acceleration along x, ay acceleration along y. So what is the displacement in x axis? Displacement is x minus x naught and this displacement along y axis is y minus y naught. And suppose ux is the initial velocity along x and uy initial velocity along y axis. So we can write it accordingly. Vx equal to what? Ux plus axt. So Vy equal to Uy plus Ayt. Now displacement along x axis, x minus x naught equal to Uxt plus half Axt square. Displacement along y axis, y minus y naught is Uyt plus half Ayt square. And also this equation is also true. Vx square is Ux square plus 2ax into x minus x naught. So this is for the x axis. For y axis, Vy square is Uy square plus twice Ay into y minus y naught. That means the way to deal with two-dimensional motion is dealing with 2D motion is resolve all the velocities and accelerations along the x and y components. Okay, first you have to choose. Now first job is choose an xy axis or choose a coordinate system. Then resolve all velocity acceleration along x and y components. Now next job is apply the equations of motion along x and y axis independently. That is, the acceleration in the x axis won't affect the motion in the y axis and vice versa. So first job, choose the coordinate axis, resolve all the velocities, acceleration, whatever along x and y axis, and then deal with the situation as if it is two separate one-dimension motions in x and y axis. See, remember, coordinate system, resolve, apply equations of motion as if they are see, again I am telling you, x and y, particle moving in this path like this. So this you can split into two 1D motions, and if you know how to solve problems in 1D motion, you can, it's like solving two problems. So I mean, a problem in 2D motion is like two problems in 1D motion. That's it. It's very simple. So right now we will be dealing with cases of 2D motion with constant acceleration, and we can extend the same concept. We see the concept will be same even if the acceleration is not constant. It may change with time, whatever. Then also you can deal with it as two separate 1D motions along x and y axis. So first let's see how to solve problems, right? And later on we'll go deeper into it. We'll go deeper into the concepts. Now we will be dealing with projectile motion. The most common problem of 2D motion is projectile motion. It's actually motion under gravity. So it's 2D motion under uniform gravitational field. Uniform gravitational field. So its situation is like this. Say this is a ground, and a particle is thrown. A particle is thrown here. Say a boy throws a ball, boy or a girl throws a ball or throws a stone, or you kick a football, this u. So u, the initial velocity of projectile, and making angle theta with horizontal. So this is the case of the projectile. So there it is G, gravitational field. So here what will be the path of the projectile? All of us know what will be the path. If you throw a stone, then obviously it will follow a curved path. This. Again it will land on ground. Okay. Now this. So this is the highest point, right? This is the highest point. Highest point of the path, and this is the maximum height. This h is the maximum height, and this is known as a range, R for range. Okay, now see, this is the case that a projectile is thrown with a speed u, making angle theta with horizontal, and this h is maximum height, g is acceleration due to gravity, okay. Now what we have to find out for this problem is that, so find maximum height, or find first time to reach maximum height or highest point. Now total time of flight, then maximum height h, now then is range, now value of theta for maximum range, that's it. Let's see, and also one more, equation of path of projectile with respect to the chosen coordinate system. With respect to the chosen coordinate system. Okay, so the coordinate system is up to your choice. So this is the problem statement. Again, I'll tell you this: gravity downwards, projectile thrown at a velocity u, making angle theta. This is a path. You have to find the range, the maximum height, time to reach maximum height, and the total time of flight. Now, as per the problem solving method, what we have to do first, we have to choose a coordinate system, then we have to resolve all velocities and accelerations along x and y components. Next, apply the equations of motion along the x and y axis independently. So that is what we will be doing now. Particle is thrown, making angle theta with the ground at velocity u. Now our first job is to choose the coordinate system. So we'll choose the coordinate system like this. Origin is here, and that's the x-axis, and this is the y-axis, and this is acceleration due to gravity g. And see here at time 0, as you know, x naught is 0 and y naught is 0. So displacement along x is actually x minus x naught. So it is x only, as x naught is 0, and displacement along y is y only, because y naught is 0. That is how we have chosen the coordinate system. Okay, let's resolve the velocity into its components, this component and this component. Now this is ux equal to u cos theta, and this is uy equal to u sin theta. So now ux equal to u cos theta, uy equal to u sin theta. Now ax, see this has no component along x axis, ax equal to 0, ay equal to minus g, because we have considered the y axis upwards. Okay. Now let's write the equations along x and y axis. First, along x axis, what will be the equations? Now this Vx equal to ux plus axt implies Vx equal to u cos theta. Now next equation, uh, displacement x. Displacement is x only, should be x minus x naught, but x naught is 0. Ux t plus half ax t square. It is constant acceleration. This is the equation. See, ax is 0, so x equal to u cos theta multiplied by t. Okay. So this is the equation for x axis, and the equation for y axis is similar. Vy equal to uy plus ayt, so implies Vy equal to u sin theta minus gt, and also y equal to uyt plus half ayt square implies y equal to u sin theta t minus half gt square. If you put the values, you will get this. Let's mark the equations. This is constant, this, this, and this. Okay, let's name these equations. Name this equation 1, this is equation 2, equation 3, and that's equation 4. Okay. So the first question has been asked that time to reach maximum height. So let's see, at this maximum height, velocity is horizontal. Okay. So for solving the first part, at maximum height, velocity is horizontal, means Vy equal to 0. So for Vy equal to 0, we will make use of equation 3. So I will make use of equation 3. So in equation 3, we will put 0 equal to u sin theta minus gt implies t equal to u sin theta by g. Now this is the answer to part 1. This is the answer to part 1. The time to reach maximum height. Now next is the total time of flight. Actually we can write total time of flight is 2u sin theta by g from symmetry. Why? Because the time to go up equal to time to come down. Or you can use this equation 4. Alternatively, in equation 4 you will put y equal to 0, because this is how the particle goes na. So that is the y axis. When the particle strikes ground, then also its y coordinates is equal to 0. So I'll put u sin theta t for the total time of flight minus half g t square equal to 0. So solving you get 2u sin theta by g. Now next, part 3. Part 3, you have been asked for maximum height. Okay, so for maximum height we can use equation. See, we have done this up to equation 1, 2, 3 and 4. See, we can add some more equations, right? We can add some more equations here. That one, v square equal to u square plus 2s for y axis. So we can add this. Vy square equal to uy square means u square sin square theta. This is it, na? Into y is the displacement, minus 2gy. So let's make it equation 4. That will be easier then. No, sorry, it's equation 5. So this 2, 3, 4, 5. Equation 5. So we will use this equation 5. See, there is a way you can find maximum height. That is, substitute t equal to u sin theta by g in equation 4. Then y equal to h at t equal to u sin theta by g. That is also one way of doing it. Or you can use equation 5, alternate equation 5, vy square at highest point or at maximum height, vy equal to 0. So 0 square equal to u square sin square theta minus 2g, and y is equal to h. So h is u square sin square theta by 2g. That is the maximum height. And next thing they have asked for, and we will solve for, is the range. Now range, as you see here, x axis, y axis, particle thrown like this. Range is nothing but the y coordinate, the x coordinate at time equal to this capital T. That is total time of flight. So we will put in equation, we will put the value of time in equation 2. So in equation 2, r equal to u cos theta, in place of time you get 2u sin theta by g. So that's u square by g. 2 sin theta cos theta is sine of 2 theta. So that is the range. Now next, value of theta for maximum range. Okay, r is maximum if sine 2 theta equal to 1. That is the maximum value of sine 2 theta. That is theta equal to 45 degree. Okay, and also note that the r is same for theta and 90 minus theta, because sine 2 theta and sine 180 minus 2 theta is same. So if it is for 70 degree and 20 degree will have same range. 40 degree and 40 degree and 50 degree you will get same range. Okay. Now, next thing was to find the equation of path of projectile with respect to the coordinate system. Now we will make use of this equation 2. From equation 2 you have x equal to u cos theta multiplied by t, and from equation 4 you have u sin theta minus half gt square. This was y. So you get rid of t actually. Find an equation in x and y, that is the equation of the path. So from this equation you get t equal to, from the first equation you get t equal to x divided by u cos theta, and put it here. So u sin theta t, u sin theta into x by u cos theta minus half g t square, x square by u square cos square theta. So y equal to x tan theta minus gx square by 2 u square cos square theta, or you can write like this, x tan theta minus gx square by 2 u square 1 plus tan square theta. Or there is one more way of writing, x tan theta, and if you take this common you can check out after substitution, you get this x tan theta 1 minus x by r. So these are the ways in which you express the equation of path of the projectile.